Excellent. That was great to hear from Yisi Liu, and also to hear from Ben Crawford. Very different situations. Ben's was kind of remote and had some pristine areas, but it led for kind of a clean test bed before testing. Please type in more questions for Yisi Liu's presentation about Chengdu, China, and the health effects that she evaluated. So I'll start with some of the questions that people have put into the chat box. So for Ben, there are a few questions here about how did you calibrate the sensors? And you mentioned that you co-located them with some sensors from the Hawaii Department of Health. How did these sensors compare to those the official sensors?
Yeah, there were several questions about the calibration, and very briefly, we co-located these outdoors with the Hawaii Department of Health regulatory instruments. And so we did this at 2 different locations on the island, at 2 of their different stations. And we did this at 2 different times during the eruption. So we feel like we got a pretty good sense of how they performed in these ambient conditions. So for SO2, there's a temperature dependence that we needed to correct for, and we ended up getting results within about 10 parts per billion of the regulatory instruments after our calibration. For the particulate matter, we needed to adjust for changing relative humidity. So for that, we did a statistical correction. And after we did that, we were within about 5 micrograms per cubic meter. There was another question, I think, about sensor drift. And over the timescales that we were looking at, weeks to a couple months, we found the drift to be negligible. But we're still measuring 2 years later, and so we can hopefully get a better idea of how long these kind of sensors are lasting and how often we need to recalibrate these in the field.
Great, thanks. I'm also seeing some questions here related to the monthly cost of running them.
Yeah, that's a great question. So we're transmitting data over cellular networks, and so the microcontrollers are there's a cost associated with each one of those. It's minimal dollars, less than $10 each per month, and then there's also some server side costs too to store that data and transmit it. So it kind of depends on the size of your network. For us, with 30 stations or so, it was a manageable cost compared to the physical cost of putting them up.
Great. Got a question here too about have you thought about using other ways to measure this? For instance, using drones, UAV. What do you think about those things?
Yeah, that's really, really cool. We did not do that. I mean, of course, we thought about it and thought that we could do some really experiments measuring in the plume. And there were some other groups doing research at the same time using different techniques, including balloons as well, to actually get in the plume. But our focus really was on people. And so we put these in communities at schools where people lived, and we were measuring at ground level where people were breathing.
Excellent. I'm going to stick still with a few more questions here for you and then move on to Yisi. Related to kind of exposure, people are asking, how did you calculate exposure to particulate concentrations? And I thought, and I actually wanted to add on my own kind of question. Did people have any observable health effects?
Yeah, those are both really good questions. I'll answer the second one first. There are some ongoing studies looking at hospital admission records during that time to determine whether people were experiencing any adverse effects more than normal. There's some groups in Hawaii at the Hawaii Department of Health that are looking at that. So I can't really speak to that directly. As far as how did we calculate exposure, we did it a couple of different ways. The first thing we did was an average pollutant level, concentration level for both SO2 and PM2.5 multiplied by the population. So we could get a person PPB type of measurement. Then the second way we did it was look at the hourly distribution. So instead of the mean, we looked at how those hourly values were distributed, and we multiplied that by population as well.
Excellent, helpful. All right, I'll just do one more for now, and then go to Yisi. Any information about, since our COVID-19 experiment, our global experiment has begun? Do you know if anyone's published data to show reduction in PM10 from highway corridors in your area, or is that really in the noise for you guys?
Yeah, that's a great question, and something we've definitely been interested in. But once the volcano stopped, the air was really, really clean there. So we aren't really able to distinguish much of a drop at all. And a lot of our places where we're measuring are in fairly rural, fairly remote areas where we're not seeing lots of particulate matter from anthropogenic sources. We do occasionally see flare-ups during really strong winds from sea spray, from salt. So that's another source of PM that we see on the island. But in terms of anthropogenic sources, it's pretty clean. So it's hard for us to really tell if there's been a big reduction in that.
That makes sense. That makes sense. All right, I'm going to turn some questions over to Yisi, and again, everyone, please type in some more things you'd like to hear from our presenters. So Yisi, someone was asking what was the longitudinal, the temporal length of your monitoring data, and how big of a sample did you need in order to validate your models?
Yes, thanks for the question. First, for the how long is our monitoring data, we did the field work in 2 months, in November and December in the city. And each of the day, we had at least a 1-2-hour trip with our subjects on the road. And in total, we have 20 subjects in the study. And before the study begins, we calculate the statistical power of how many samples we need. And the results should we need around 15 subjects to, in this repeated measurement study, to reach a statistic power of 0.8. So we're kind of confident that this sample size of 20 subjects with 8 repeated trips would be enough for this study.
Interesting. People asked a couple of questions that were really about your analysis. So one has to do with what is the implication of the seemingly contradictory correlation between Sham masks and better health outcomes?
Yeah, it's it's a very interesting and confusing point in this study for us. When we saw this contradictory correlation, we thought about 2 things to consider. First is the masks as a facial mask themselves, and the second is this particular population. For the mask, we were thinking how well does the mask perform in this real world. So we use this mini paper to provide the positive pressure in the breathing zone for subjects, because what we want to deal with the fit issue of the normal N95 mask. Because sometimes if the N95 mask doesn't fit well with the subject's face, then there will be leaking, and the effectiveness of the mask will reduce and actually won't work pretty well. So we did the fit test for this mini paper first and see how actually performs, the mini paper performs. And this fit test tells us the mini paper would reduce at least 50% of the ambient particles, although it doesn't work that well, as well as a normal N95 mask, which would reduce 99% of the particles, but still it can remove at least half the particles. So so for the mask side, we think it actually works for the subjects. Then it comes to the second aspect of the question as a population. because this population is a group of young and healthy adults. And we saw previous literatures on facial mask. Some of the study found some effect of the facial mask, but some not. And we saw there are two studies found effective effect of the facial mask were on a group of subjects with cardiovascular diseases. So it's maybe maybe it can be explained as the facial mask might be useful for subjects with some cardiovascular or respiratory health issues, but maybe not effective way to protect health for healthy population.
Okay, thank you. We're almost at the end of our question and answering period for now. So these questions will be answered and posted on the website. Quick, for less than a minute each for each of you, Ben and for Yisi, start with Yisi. What's the accuracy of the sensors when co-located with official air quality monitors and the calibration methods? Just very short.
Yeah. So this sensor we used the sensor from Plant Tower, and it's a pity that we couldn't do the collocation in China because we have no access to the central station. But we did the collocation in Seattle, in the U.S., and it performs pretty well. Actually, we have already published a paper describing this, so I can share the link if people are interested in the performance of the sensor.
Excellent. Excellent. Ben, in just a couple of words too, could you answer that same kind of question? Accuracy of sensors compared to the official monitors and calibration methods?
Yeah, sure. We were within about 10 parts per billion for SO2 compared to the reference monitors, and within 5 micrograms per cubic meter for particulate matter compared to the reference sensors.
Very good. We're going to call it a wrap for this period. Thanks to Ben Crawford and Yisi Liu for your presentations, and I understand you'll be available for at least some portion of this to look through the questions online if you have a chance to look on the chat. And again, people who are listening, we can see the answers to these that will be available from the Air Sensors International Conference website.